In this video, we will discuss about the gene regulation and expression. We will focus into the leg operon. The leg operon system consists of promoter, operator, and structural genes that consist of leg Z, leg Y, and leg A. Adjacent to the leg operon system is the regulatory gene leg I. Transcription of the genes will produce mRNA strand. mRNA from the gene leg I will be translated into repressor protein. Leg Z will code for beta-galactosidase. Leg Y code for permease, and leg A will code for trans-acetylase. The function of the repressor protein is to binding to the operator and switching the leg operon off. The function of beta-galactosidase is to hydrolyze lactose into glucose and galactose. Permease will form a membrane protein that transport lactose into the cell. Trans-acetylase will detoxify other molecules entering the cell via the permease. In the absence of lactose, regulatory gene leg I transcribed and translated into repressor protein. Repressor protein bind to operator to prevent RNA polymerase from bind to the promoter. No transcription of structural genes and no enzymes produced. The leg operon system is switched off. In the presence of lactose, some of the lactose will be converted into allolactose. Regulatory gene leg I transcribed and translated into repressor protein. Allolactose bind to the repressor protein. Repressor protein change its conformational shape. This will cause the repressor protein cannot bind to the operator. RNA polymerase bind to the promoter and transcribe the structural genes to produce mRNA strand. The mRNA strand will be translated into enzymes. The genes leg Z will code for beta-galactosidase. Leg Y will code for permease, and genes leg A will code for trans-acetylase. The leg operon system is switched on. In the absence of lactose, regulatory gene leg I transcribed and translated into repressor protein. Repressor protein bind to operator to prevent RNA polymerase from bind to the promoter. No transcription of structural genes and no enzymes produced. The leg operon system is switched off. If the regulatory gene leg I become mutated, it will be transcribed into mRNA, then translated into inactive repressor protein. Inactive repressor protein cannot bind to the operator. RNA polymerase can bind to the promoter and transcribe the structural genes into mRNA strand. The mRNA strand then translated to produce enzymes. The leg operon system is switched on. This process occurs continuously without being affected by the absence or presence of lactose. That's all for now. Thank you and see you again in the next video.